In example 3, we're asked to use Newton's quotient to find the derivative. Now, we only will do this if we are asked to use it. Okay? Otherwise, we would just differentiate normally. So Newton's quotient is the definition of the derivative. We need to use a limit. So the limit as h approaches 0 of f of, and maybe I'll write this in its general form. So f of x plus h over f of x, minus f of x over h. So this is basically when the rise and run as the run goes to 0. Okay, so this is slope. So for this particular example, it's going to look like this. The limit as h approaches 0, and it's going to be 1 over x plus h plus 1 minus 1 over x plus 1. And that's all over h, and we want to let h go to 0. Now the key to this is we need to get a common denominator here. Okay, so we're going to get a common denominator. I'm going to put the h in the denominator to start, and then we need a common denominator for this. So we're going to end up with x plus 1 minus x plus h plus 1 in the numerator, and then the denominator of this is going to be x plus h plus 1 times x plus 1. Okay? So I'm just going to clean this up a little bit, so it's going to look like this. And then I have my h in the denominator, and I need to get that h to cancel out. But as I look at this, lots of things are going to cancel out in the numerator. So if you notice, I have an x minus x, I have a plus 1 minus a plus 1, and really what's left over in the numerator is just an h. And I end up generating a factor of h in the numerator. In fact, it's negative h. And that negative h will cancel with that h that I had in the denominator. And then I just have to evaluate x plus h plus 1, x plus 1. Okay, just going to straighten this out a little bit. And so it looks like that. And now, because those h's cancel out, I now no longer have the divide by 0. So I can plug in my h value of 0, and I end up with this limit is equaling negative 1 over, this becomes x plus 0 plus 1 times x plus 1. Well, that simplifies to negative 1 over x plus 1 times x plus 1, or x plus 1 squared. So there is my limit. Okay, so this means that the derivative f prime of x must be negative 1 over x plus 1 squared. Okay, and these are the steps to get there, and that's using the Newton quotient. Now, I could have differentiated this and gotten the same thing, but this is how I show the definition of the derivative, or the Newton quotient, to get the same result.